these are really general purpose things, but there are more specific protocol related scanners that take advantage of specific types of protocols, or even very specific protocols, right? So first of these technical like service level protocols is ICMP, of course, which is normally used just to verify the connectivity in the network, right? So the easiest way to do that is to ping a host just by host name or an IP address. Some versions of it in some operating system distributions are careless, I would say, are careless enough to accept this -B option that allows you broadcast ping requests to certain networks, right, to certain network segments, which is not a good thing, I think. But back in the day when the internet was relatively safe, that was okay to use, I guess. But currently you have to be more accurate than that, and for that there is a specific mode of operation in Nmap, which we will discuss a lot further in this tutorial, which is designated by this -SN switch, and what it does basically just ping sweeps the network or the host that you have given to it. Okay, so it's doing it really fast. It can resolve the names or back resolve the IP addresses in the way, depending on whether you give or don't give -N switch to it. So just by giving this -N switch, you will speed it up even more, so there will be no DNS resolution in a way. So I think every time you are talking about ping sweep, you have to perform a ping sweep. You have to stick to this nmap -SN-N command. Okay. The second really fast way to scan the network you are physically connected already to, right, is using ARP. What is ARP? It's a level 2 protocol, right? That is MAC address based. Okay, so issuing this command ARP-A will just give you your current ARP table. It is really security sensitive because spoofing entries in this table, for example, can just route all your traffic to a host that is different from your default gateway. So for example, you're trying to get out of your network, but if someone has successfully spoofed your ARP table and your default gateway's MAC address is now pointing to some other device, right? So you will be a victim to a man-in-the-middle attack. So keeping that thing in order is really important, and we can get a lot of information out of it. So ARP scan is relatively low signal noise tool that is almost invisible to any security monitoring software on the network, and every time you have to enumerate the network you're already connected to within the same Ethernet segment, you have to use that. Or Nmap, of course. And as to TCP scanning, yeah, it also can be very useful when we are talking about active hosts enumeration. So we are not talking about services yet, but still, we can assume that some hosts in a really monocultural infrastructure like Windows Active Directory domain, are running some specific services, like SMB related services on ports 445, for example, or 138 or 139, sorry. So these things are normally there, they are open, and if we know that system administrators actively use RDP, we can assume that ports 3389, right, are also open everywhere. So we can just use Nmap and designate this list of specific ports to it and see what happens, because ICMP scanning is fast, but it's much slower than TCP. especially when run with root and in a scene scan mode. Okay. Also, there is mass scan. Yeah, so that's when Nmap is doing well in a general sense, right? So it's a general purpose scanner. Mass scan is very TCP related. So Nmap2. So these two are wicked fast, really. So you can scan the whole Yahoo or Google presence in the internet by ports 80 and 334, okay, like in a matter of minutes by mass scan. So it's really cool for enumeration too. You do not have to grab banners, you do not have to analyze or fingerprint what's going on those for services, those TCP service ports, but still, just for the sake of enumeration, you can use that really fast. Okay, so these are things that are doing their job more or less accurately, right? And they are normally used in the real world. What is this notion of custom tools here? So just to give you an idea, this is this is network stuff, you know. So it's a really complicated thing. And the good thing about the people who are coming from networking world to penetration testing is that they are already prepared to the most of theoretical stuff they will encounter. So they will be able to understand how things interoperate through the network, and it will give them a really good basis for understanding of what's going on inside of those things. Okay, so you see the applications, you have no idea how they are designed, how all these .NET, Ruby on Rails, or Swift frameworks are affecting the architecture of specific applications, but you know what data is transmitted between them, between the client and the server, between different peer-to-peer applications, and so on. So this knowledge, if you have it, if you have this networking background, it will be very valuable in penetration testing. And the first thing you can apply it to is this custom tools. So these are the tools that hping and nping are mostly equivalent, but nping is it's contained in Nmap installation. Okay, so these are the tools for crafting different packets and sending them, of course, and then listening to what is coming back. So this is like packet crafting toolkits that can give you an ability to just pretend anything on the network. You know, so this can be really cool when you are trying to maintain a low profile on the network, first of all. Yeah, so we will do something really custom, not to get caught by signature-based security monitoring tools. Okay, so this will come handy. The second one, Skeppy. The Skeppy is a tool that it's a framework. It's rather a framework that extends your Python scripting abilities enormously in terms of networking. Okay, so it's just a module. Technically, it's just a module and the interface to it that allows you to build web clients, TCP clients, UDP servers, web servers, all this type of stuff. So any component of network interoperability in a matter of minutes. Okay, and it's really optimized, and it's command line based. So in the situation, for example, when you are trying to like imitate a communication between a bot, yeah, a malicious bot software, and its command and control server, right? Skeppy is your first and the last stop. So you will do anything related to that by Skeppy only. Okay. In the situation when you have a large pickup file, like you know, I don't know, like multiple gigabytes of pcap network dumps collected from the network, yeah, there is not much you can do with Wireshark, because it will be really resource consuming to open it and filter and operate and process it in Wireshark in a graphical mode. Scapy, on the other hand, it can parse these large amounts of information really effectively, really fast, and with really low resource consumption. So take a look at it. It's really like the mode du jour right now. So passive is like not doing anything really. Okay, so just as the contrary to active means of active host detection. I'm sorry for a little mess here, but on the contrary of this active hosts enumeration, we will have another way of getting insight from what's going on in the network really passively. So what we are doing here, we are not doing anything really. So we are just hanging out there and listening what comes to our interfaces on the system. Yeah, not responding to anything, just listening. How can we do it effectively? First of all, there is this mode of operation of an Ethernet device or Ethernet interface in the system, so-called promiscuous mode. That is basically just listening to everything that is received physically. Okay, so there should not be any logical reason to catch that, but it is caught anyway. So from that we can get much more information that is intuitively acceptable by your mind, you know. So there are protocols, really interesting examples of leaking enormous amounts of information out there without any reason. For example, there are modes of operation of Dropbox client-side software that are broadcasting over the network some beacons that allow them to identify each other and synchronize between different devices belonging to the same owner, right? So we just will see that something is transmitted on the port number 500, I guess. Yeah, I guess so. So you will just see it, and you will see that there are drop boxes that are identifying each other and are authenticating each other by public keys, and you will have a lot of fun playing with that. Okay. Other things can be really service supporting requests and broadcasts that are overused by Windows infrastructures, for example. So this will give you a lot of information of what hosts are there and already provide some insight about what services they are running and what operating systems they are executing and so on. And so let's go to that part where we detect the services and then fingerprint the services and operating systems.